Hi, Chris Mc Loone here with Fire Apparatus and Emergency Equipment. Welcome to this episode of our podcast. We're going to be talking about moving water again. It's been a while since we did one of our water delivery podcasts. In fact, I think it was with you, Andy, back at FDIC. It was the last one that we did when Bill had to cut out a little early, unfortunately, due to being a bit under the weather. So it's good to have you both back. Bill, hopefully next year you'll be able to stick around at FDIC because it is much nicer having the two of you sitting on physically on either side of me. So anyway, welcome back. This month or this episode, we wanted to talk about building pumpers, whether it be a pumper or a pumper tanker or a tanker, for high volumes of water, to flow high volumes of water. There are certain nuances to doing this if you're going to start a truck from scratch. Now, it kind of goes against a little bit of what we've talked about in the past, because usually I bring up when, Andy, when you're showing us pictures, you're like, oh, well, that is an older rig. So don't let it fool you. You can move a lot of water with an older rig. But this one, we're talking specifically, you're ready to build a truck, from scratch, and you're ready to do it. And this is how we're going to suggest that, just some things to think about as you are building the truck. So before we get into the unit itself, there have got to be a number of pieces that you want to have. And I'm just talking about whether it's rig components, whether it's appliances, whatever it is, there are certain things you need in order to get a truck ready for the large volume of water flow. So if you could just, Andy, I'll start with you. Just kind of walk me through a little bit of some of those things that you want to be thinking about even before that you're going to need, even before you sit down to put pen to paper.
Yeah, absolutely. So one of the biggest things that I like to recommend to people is, regardless of what you're trying to build, whether in this case we're talking about a water moving machine, or whether it's an aerial ladder or a tanker tender, anything, the most important first step that anybody or a committee has to do is sit down and identify what the mission of the unit is, right? What is the overall mission of this unit, and write it down and pay attention and always reference whatever that may be. Because a lot of times when you're building a new rig, it's very easy for the whole process to go off the track, so to speak, and you take and go down a bunch of different rabbit holes, or, this looks nice, we want to do this, and get sidetracked from what you're really trying to do. So the first step is identify what the mission is. And if the mission is we want to build a water supply support piece, well, then that's going to lead you down potentially a different road than, hey, I want to build a really functional attack engine that has the ability to move big water, right? To me, in my mind, those are two totally different rigs. And the attack piece very well may have a lower hose bed, the ability to deploy hand lines easily and efficiently, whereas the rural water or mobile water or water supply support piece may carry a larger booster tank. The hose bed may be a little bit higher, but it may have a split bed for a large diameter hose to lay dual lines. So if I have a mission clearly defined, it's going to make it so much easier for me to say, hey, these are the things that I really need to focus on, and these are the must-haves. We have to have X, Y, and Z on our rig, and the other thing is just fluff, so to speak.
Bill, what about you?
Andy hit the nail right on the head. It starts before you talk to the engineers or the salesmen. Salesmen are just trying to sell you the truck. You need to have that plan prior to talking to them. Like Andy said, depending on what type of apparatus we're building is what we want to do with that apparatus when we have it in our station. We want to have the idea to be able to tell those engineers how we want it done. What happens a lot of times is we tell a manufacturer we're looking for a fire truck. We tell them what we want, and they send us this picture, and it looks great. It looks much better than the apparatus we have currently, so we'll make do with it, even though it don't have all the bells and whistles that we want, what we really need it for. So before you even talk to those manufacturers, have the plan before that and give that to them when you do start to talk to them.
Well, that brings up a very important point right now in this environment that we find ourselves in when we're talking about apparatus purchasing, which gets into a slightly different, slightly different topic. But I mean, it really does lend itself to it. You need to get this right from the get-go these days, because you can't be replumbing a truck, at the engineering conference. You really, really need to get this done at pre-con to make sure that you have, and that all starts, just like you said, the mission of the rig. Before you even put pen to paper, it's that mission, and it's getting all that nailed down. But one of the things too about that is getting the nomenclature right, and that's my next question, Bill. Is high volume the same as high flow when we're talking about moving water? Is high volume high flow, or are they completely different things?
They're somewhat the same, and yet somewhat a lot different. High volume focuses on the amount of water we're using, and then we determine the flow by how fast that water is moving, the penetration that we're going to be able to get through to our fire. So when I think of high volume and high flows, yes, it's the amount of water, but the flow pertains more to the speed of that water and the penetration of that water.
Do you have to make them both when we're doing this? Are we talking about is there a difference between? I mean, kind of like what you were just saying a second ago, Andy. I mean, is a truck designed for high flow one thing and high volume another? Or is it one and the same? Can you or do you plan for high volume and high flow?
Yeah, I would say, right. I would say the goal is, right, you want to identify what is a realistic flow that you're trying to shoot for, right? What is the realistic maximum flow that you want this rig to be capable of achieving? Right? Just because I purchase a 2,000 gallon per minute pumper doesn't necessarily mean that I'm realistically expecting a flow rate of 2,000 gallons a minute all the time. And if I do not plumb the rig correctly with the appropriate number of intakes and with good discharge configurations, then yeah, I have a stamp that says it can flow 2,000 gallons a minute, but is that realistic on my fire scene, right? One of the things that we talk about a lot in my classes is, the difference between pump testing and what you do on the field or on the fire ground, right? And a lot of people, when we look at pump testing and we look at pump testing a 2,000 gallon per minute pumper, right? Most people understand that is going to involve using multiple discharges with multiple hose lines connected to several different monitors at a test pit and all this, that, and the other. And that's how they get their 2,000 gallon per minute flow from a draft at 150 pounds net pump discharge pressure. But then we try and go on the fire ground and we try and flow that same 2,000 gallons a minute. But tactically on the fire ground, we're only using one large diameter discharge and 5-inch hose. And people wonder why they either can't achieve the 2,000 gallon per minute flow, or the engine is running at such a high RPM that it sounds like it's getting ready to take off into outer space, right? The problem is, the hydraulics and the physics behind the flow and the volume is the same during pump tests as it would be on the fire ground. So if I'm serious about, it's one thing to have a 2,000 gallon per minute pumper, but it's another thing to have a rig that is capable of moving that kind of volume easily and efficiently on an actual fire ground. And plumbing on the discharge side of the pump is really, really important to do that effectively. So that's what you really want to be thinking about. And on the intake side, I'm going to steal a page right out of Dennis Laguerre's book. This is one of my favorite sayings of his, right? Most rigs in the American Fire Service are over discharged and under intaked, right? Most of our rigs do not have enough intakes on the rig itself to sufficiently support all the different discharges that are plumbed on the apparatus. So I think that's another one of your questions, and I can save that answer for a little bit later. But for me, a rig that I'm designing specifically for large flow and large volume, I need a lot of intakes on the rig strategically placed.
It is one of my questions for later, and I was gonna just say, nah, just do it now. But based on what you just said, it kind of leads me into another question that I had for you, and that is, I've sat through a number of pump operations classes during my career. I'm not professing to be an expert on it, but I've sat through enough of them that, like one was just to get me qualified to drive the trucks, and like gives you the working knowledge and all that kind of stuff. And then there were a number of research, along the way. And then every once in a while there would be a township school where we threw something in there. But one of the phrases I have often heard whenever we're talking about any of this stuff is if you have the water. So from both a rural perspective and a suburban, like a suburban/urban perspective, what does that mean? How do you you're building a truck, you want to move a lot of water, but what if you don't have the water? What do you got to do in the beginning to make sure you have enough water to do what it is you're trying to do? Bill, I'll start with you because I think you have a perspective from both the rural, your volunteer company, and your career department for that.
Yes, when talking about do you have the water in the rural side? Do we have enough tankers on the road coming our way to give us enough water to be able to use for the fire ground? Also, in a rural setting, you have a hydrant. When you see a hydrant sitting on the side of the street, you think, "Oh, we got plenty of water. We don't have to worry about any other water source." But what if those mains are only 3 inches or 3 or 4 inches? Which we have that a lot in the area where I live and where I volunteer. When we're trying to get larger volumes of water, it's not going to happen out of that single hydrant. Where at work in the suburban area, we have hydrants with 20-inch mains plus, and we can get all the water we want out of 5.5 to 6 inches of water out of that hydrant if we're heavy hitting that hydrant. So we can get that larger volumes of water out of the suburban areas, or at least where I work, where I can't get that out of a hydrant in the rural setting. So in the rural setting, a lot of it determines how many tankers do we have on the ground coming our way to be able to set up. Even if we have a hydrant in the front yard, we still may supplement that flow with tankers, tanker shuttles.
Is it worth putting in the effort to
if you need those
to build this mass, to build this truck that's designed to, move all this water? It calls into a whole question if you can't get the, but if you don't have the water, is it even worth putting all the work into it?
Sometimes it doesn't feel that way. When if you have enough water, if you have enough tankers in your area to be able to supplement it, it's definitely worth the squeeze. But if you can only get so much out of a 4-inch main, it's not going to give you any more. So if you have to supplement with tankers, then that's what we have to do.
All right. So it's not, you just need to plan, really, is what, on your operational side.
Yeah. Have everybody build a pond in their front yard. That'd be great.
Andy, what about when I talk about when we talk about, well, if you have the water, you can do it. And we're talking about that on my end whenever we're talking about master streams and stuff like that as well. But like from your perspective, how important is that to make sure that that you can get the water you're trying to move?
Yeah, absolutely, and that's the thing, right? It does me no good if I am in a really rural environment that, like Bill's saying, has really poor municipal water and maybe doesn't have enough tankers to support stupid flow rates, right? Maybe I don't need to buy or build a 5,000 gallon per minute super pumper, right? Because it doesn't matter if I hook, it doesn't create water, right? The pumper does not create water. It can only make use of what's available to it, whether it's hooking to a fire hydrant or drafting out of a static source. It can only make use of what is there. Now, that 5,000 gallon per minute super pumper will be able to move that flow from a static body of water, a pond, a lake, or something like that. But if it's being used at a dump site, well, I mean, if I don't have enough tankers in my shuttle route, then there's no way I'm going to get to that flow. So that's where, you as an organization, a lot of people will sit here and say, well, how big of a pump do we need to buy? And this, that, and the other, right? It makes sense to realistically say, right, what are we trying to achieve? What is realistic flow wise for our organization? What is realistic for a single engine to be capable of moving, right? Assuming that it has the water. And that's always, unfortunately, I hate to make the statement, but that is the assumption, right? We're assuming that if we're using it in the scenario that we have it set up in, that the water is in the ground or whatever it may be to actually make the juice worth the squeeze.
Well, and, I guess part of where I was going with that is, the manufacturer will build whatever you ask them to build, but you have to be realistic about what it is, what your capabilities are, not only in your company but in all around the mutual aid places. If it's never going to have to do that, you got this very well put together, well designed truck that can move some water that never will, so I guess that was just kind of where I was going with that. But let's start getting into the design considerations for a rig like that. I wanted to start with the plumbing, which sort of will dovetail into, the intakes and the discharges and all that. But when I'm thinking of plumbing initially, when we talked about that, I was thinking of the internal plumbing. I was thinking of how can I set it up behind the pump panel, within the body and all that, so that I can get, assuming that I have the water, so that I can get that water out and move it, at a really high volume of water. And I guess, there are simple things like, well, the fewer bends you have, blah, 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 blah. But yeah, and I'm sure you'll mention that. But there's also, does it make sense to have, to go above and beyond whatever NFPA is telling you should be, your minimum diameter piping inside? Like, should you jack it up to, depending on what you're doing? So I'm rambling there. I see Andy shaking his head, so he already knows where I'm going. So Andy, I'll start with you on that one.
Yeah. So the simple answer is, like you said, they'll build whatever you want, right? So if you're using NFPA 1900 as a guide to build a rig, as you should, right? One of the things that you really want to pay attention to and look at is and understand is that the standard recommends and lists what the minimum discharge requirements are for your rig. And the standard states, and old 1901 stated this, that the rig has to have enough 2.5 inch or larger discharges on it in order to flow its rated capacity. The rule of thumb has always been that a 2.5 inch plumb discharge is capable of flowing at least 250 gallons a minute with a minimal amount of friction loss within the truck, right? So it's negligible, not something that you really have to worry. Now, a lot of people will look at this and say, well, hold on, I have a 2.5 inch discharge on my rig, and I've gotten 500 gallons a minute out of it. So what are you talking about? They can only flow 250. The key here is it'll flow more, but every gallon per minute that you go above that 250 range, what ends up happening is now you're going to start seeing a climb in internal plumbing loss, and there gets to be a point where it doesn't make sense to try and flow much more than X gallons a minute through that individual discharge. So with all that being said, where I see this a lot is, and options in plumbing, is when we get to large diameter discharges, all right? One of the biggest things that I recommend to customers that are building a truck is spend time and clearly specify with your apparatus manufacturer what size plumbing you want for your large diameter discharge. And do not just write it in your spec as broadly as we would like one large diameter discharge on the rig. Because to an apparatus manufacturer, that doesn't really tell them anything. That tells them that you want to have some way to connect your Stort's 4 or 5 inch hose to a discharge. And if you don't specify, you could end up with 3-inch plumbing on your large diameter discharge. Now, when you look at the standard, 3-inch plumbing only has to be capable of flowing 375 gallons per minute through it with a minimal amount of loss. That's not a lot. And your 4 or 5 inch is capable of moving a lot more than that. But it's hooked to a discharge that has really tiny pipe and may have a lot of bends and stuff like that. On the extreme opposite end of that scale, if you look at the standard, it says that 6-inch discharge plumbing has to be capable of flowing at least 1,500 gallons per minute through it with a minimal amount of loss. And that's fine. You might think that my recommendation is going to be, hey, go and spec 6-inch plumbing on your pumpers. That's not what I'm saying, because you're going to spend a lot of money on that discharge plumbing. And then in order to make it hydraulically effective, what you also have to think about is they got to figure out a way to plumb all that with minimal amount of bends. And that's ultimately going to cause your pump house to creep and get bigger and bigger and bigger and bigger. And now we're affecting the wheelbase of the rig. Your rig's getting longer. It may not be maneuverable, right? So all of that is things that you have to take into consideration. So with all that being said, what I recommend specifically on large diameter discharges, some manufacturers will do this as a standard option. Others, you have to prompt them. But I always recommend that as like the gold standard for a municipal pumper, not a super pumper or an industrial pumper, but for a municipal engine, whether it be urban or suburban, I like to spec 4-inch large diameter discharges, because the standard says that it has to be able to flow at least 625 gallons per minute with a minimal amount of loss. Now, what I'll tell you is, in my experience, most 4-inch plumb discharges, they will easily flow 1,000 gallons a minute with no problem. If I need to start getting into that 2,000 gallon per minute range, what I really need to be thinking about, honestly and truly, whether I'm in 4-inch or 5-inch, I need to be thinking about putting a second supply line on the ground, especially if I have a lot of length on the ground, separating the source and the fire scene anyway. So you're going to be better off trying to put a second line on the ground between your supply pumper and your fire scene than trying to jam it through one discharge. So with that, here's my next recommendation. And I've seen it a bunch on a lot of different rigs. I was working with a rig today in Hanover County, Virginia, that had this exact setup, and it's beautiful. If you expect to potentially have to do parallel supply lines routinely and move 2,000 plus gallons per minute, all you need to do is specify that you want 2 large diameter discharges, each of them plumbed with 4-inch plumbing. Now, all I have to do is hook my second supply line to that second discharge, and I'm ready to go, right? The alternative, if you don't have a second large diameter discharge, is you have to start using manifolds and multiple 2.5s to go into the manifolds, like we discussed in the end of the year recap with those photos back in December, January. So you can do it. It's just more work and appliances and stuff like that. So from the discharge side of it, 2 4-inch large diameter discharges, if you're serious about getting rid of a lot of water on the fire ground, that's how you do it efficiently and effectively and realistically on the fire ground.
So what about you? Any plumbing recommendations?
Andy said exactly what I was going to say. Obviously a little longer than what I usually answer a question, but that's perfect. What I have seen done, a lot of pumpers have those 2.5-inch discharges, and to be able to get the extra water out of it, I've seen a lot of departments take a a 6 or 8 foot section of 2.5 inch or 3 inch hose, connect that to a manifold of some type, and push that water forward to that 5 inch instead of just using that single 2.5 inch storage fitting. Andy mentioned the 6 inch discharge. It's super expensive, and it's still reducing itself down to a 5 inch anyways. When I don't know too many people in our industry that has larger than 5 inch supply line. So it's really not worth the money to get that 6 inch. We have 4 inch on all of our large diameter discharges.
Does it make sense? I was thinking about this, and maybe it doesn't matter. Maybe it does. I guess taking away the "it depends" answer, because a lot of times that is what it is. Do you kind of just, in order, again, assuming you've got the water, let's not get into the 6 inch piping, but you're going to do the 4 inch piping. If it's going to make your pump panel bigger, if it's going to make the truck a little longer, do you just throw that away sometimes and just say, oh well, it's this is what we're building it for, so this is we have to do what we got to do. It seems like like we were talking about before, the fewer bends, like the longer straight runs, or the more straight runs you can have, the less internal loss there's going to be. At least that's logically what I'm thinking. I could be totally wrong on that. So, like, Bill, do you just throw that away? Do you throw away like the overall length requirements if you can, and just say, hey, this is what we're building this to do a certain thing, and in order to do that, it's just going to have to be longer. I mean, is that like a thing, or can you play with the plumbing internally to really to still do this, to do the same thing? Not saying you would have like a 24 inch pump panel, obviously, but are there things that you can do? I guess the real question is, do you just throw away overall length if you have to?
You mentioned the term "if you can." It all depends on and I hate to say the whole "it depends," but a lot of the people we're talking to live in, or they have firehouses that they can't get the apparatus in the building because if it's too long and too high. So if you can, if you have the larger buildings where you can put a larger fire truck in it, then yes, it's worth it in the long run, because your apparatus will be able to run at a lower RPM when your plumbing's not having a ton of bends in it. But a lot of places they can't. They have to spec a fire truck based on the building that they have. And we, at Fayetteville, before we got to the building we're at now, we had to spec an apparatus based on the doors that we had, because they only had 10-foot doors. So we had to make everything short, and it wasn't a very long building. So our pumps, if you open up the back or open up the pump panel, there was all kinds of bends in those elbows, but all it was creating was a bunch of friction loss, which made our trucks run higher RPMs and just harder on the trucks in the long run.
And before I jump into the intake discharge stuff that Andy was probably going to get into, we'll get into the number and all that in a second. But again, I think we talked about this in a previous episode at one point. Is it better, like, where my head was going was, like you do a front intake and it comes in and it goes down or goes up and over, and then it does the thing again. A lot of times the rear intakes, they're usually straighter. But for doing this, do we really only want to come into the steamer connection on the side, or like where do we want to bring the water in to maximize all the work we did on the plumbing? Whoever wants to take that.
Okay, yeah.
whoever wants to take it. I'm sorry.
So in my opinion, right, if I'm building my perfect engine, whether it's that, larger flow capable attack engine, or something that is nothing but a water supply piece, or a wagon, as some people will call it in certain parts of the country, right? For me, 100% without a doubt, non-negotiable is you're going to have intakes on all four sides. You're going to have a front intake, two sides, and a rear, right? Non-negotiable. And certain intakes are going to be better for you than others. But what I love about having those extra intakes is it gives you options, because the fire ground isn't always perfect. And we know that, yes, going into a side intake is obviously going to give us the best flow because it's a direct shot into the eye of the impeller and all that good stuff, this, that, and the other. But the scenario and the environment that I'm working in may not allow me to use that as my first choice, right? Because of positioning or what have you. So having the option to have front and or rear intakes, or like some rigs do, some people build their rigs to have dual steamers on one side of the apparatus, right? It just gives me more options for the ever-changing and evolving fire ground that I'm dealing with, right? So to me, that's one thing. But also understand that, yeah, right, certain intakes, they everything comes with an advantage and it comes with a disadvantage. So I need to know what the disadvantage is going to be if I'm using the front intake, right? The advantage is typically it's easier to position for. It gets me fast water. I usually, if I'm drafting out of a dump tank, it's one section of sleeve versus two or three, right? Those are the advantages. The disadvantage is there's going to be plumbing loss, right? There's friction in that front intake plumbing, and you're going to lose some volume because of friction. Now, how do I fix that? Well, I need to understand that if I need more water, I'm going to either have to not use that intake, or if the scenario requires me to use that intake, right, I'm going to have to twin tube or double tap my hydrant or do whatever I need to do. So understanding that there is no one perfect intake that you're going to hook up to and it's going to be all that you need forever. Rather, you should get in the habit of understanding I need to use multiple intakes in conjunction with one another in order to be efficient for these large flow incidents. But there's another reason why I like a lot of intakes on my rig. Not only does it allow me to take water in from my source, but in more complex operations where I am flowing water at the fire scene, it allows me to share water with multiple rigs at the same time via an intake to intake connection, like we talked about in one of the previous podcasts. So if I only have two side intakes and I have water coming out one side, I can only share water with another rig on the other side. Whereas if I have four intakes, I can have two feeds from two different hydrants from two different engines that are pumping those hydrants coming into me, and then share water with an aerial and another pumper, right? So it allows me to build more complex, larger scale water supply operations at my fire scene. It allows me to receive water and share water.
Okay, so having said all that, let's get into the nuts and bolts of the discharges and the intakes, because there are certain hydraulics that we need to think about. There's flows getting in. We can talk all day about, well, I recommend this, I recommend that, but there are certain things that you gotta make sure you spec on the intake and discharge side to ensure that you're compliant with the standard and that you're going to get everything out of the truck that you want. So Andy, get us started on the intakes and discharges. I'm picking you because you were the one who got us on the path in the beginning of the podcast anyway. Not keeping you out of this, Bill.
Here's the thing, right? The intakes, this is one of the things that, Chris, you mentioned staying in line with the standard and everything like that. And this is really important because a lot of people don't recognize this. If you're serious about moving water and moving big water, what everybody needs to understand is a piece that is absolutely critically important to have, especially on the intake side of the pump, is intake valves on all your intakes, right? And you might be sitting here saying, well, duh, doesn't it come that way? The answer is no. The way the standard reads, the standard says that you only need one intake valve on the intake side of the pump. And if you have a 2.5-inch auxiliary intake, the quarter turn auxiliary intake valve, that counts as the only intake valve that you need. So you could, and I've seen it happen, you could order a rig with 2 large 6-inch intakes on the sides of the rig that have no valves on them. They come from the factory blind capped, and they have an auxiliary with that quarter turn valve, and it meets the requirement of the standard, right? Now, I'm not advocating this because I'm tied in with some valve manufacturer or anything like that. But the way I think of it is you wouldn't buy a truck or a pumper or anything that did not have a discharge valve on a discharge, right? Because that would mean water would always flow out of that discharge. So why are we getting rigs? Why are we getting pumpers that come with intakes that don't have a way to control the flow of water into the pump? So this is where the customer and the individual that's building the rig, you have to do your homework. I recommend that you have a valve on all your intakes, even if you're doing drafting, and that's a whole nother discussion. But this is where the onus is on you to figure out, okay, do I want to put and spend money on an internal intake valve, or do I want to go with an external intake valve, right? And they both have their pros and cons. And that was, in fact, one of the first podcasts we did on this show was talking about intake valves and everything like that. So that's where you need to figure out and make sure you tell your manufacturer, hey, we do not want an internal intake valve on the driver's and officer side because we are going to put brand whatever intake valve. It's going to be an external intake valve, and it's going to go here and here, right? Because if you don't tell them that, they don't, it's not that big a deal. It's just going to come with blind caps, and you're going to be riding around with no way to hook your 5-inch or your 4-inch to your pump intake. And I've seen it happen in my travels where that's how they run.
Bill, intakes and discharges. We're designing this to get we're designing this for high volumes. What do we need to worry about with the intakes and discharges?
So we can spend all the money in the world on the apparatus, but if we put cheap appliances on it, we're only going to get that amount of water. That'll be our weak point. And just like we've talked about with strainers, they're not all the same. So your intake valves are not equally the same. When you tell a salesman that you want an intake valve for your apparatus, they're going to give you a cheap number because they want that bid. And so they tell you, I can get you an intake valve for $500 where the other one was $1,000. So what do? We all take the $500. Well, it's not going to flow the same amount of water. So when you have those large fires and we're trying to get that 1,500 GPMs or 2,000 even, we're not going to be able to get it. And we're like, what's wrong with this truck? Why is it not flowing what it says it will? Well, it's because of the appliances we put on there. So just like Andy mentioned, do your homework, understand what appliances flow, and then buy what's appropriate for what you need.
Is there anything else we need to worry about? Like I said, like nuts and bolts for number of intakes, number of discharges. Do they all have to match up? Is it just GPM that you're trying to match up, or are you trying to match up the volume of it? Talk to me just real quick about that. Is that even a consideration, Andy?
Yeah. So one thing that Bill touched on, and I really want to make sure everybody understands, is the last thing you want to do. Bill mentioned do your homework and look at valves and everything like that. The last thing you want to do is go through all the work to build this amazing water moving machine, and then go and get the cheap intake valve that only has that 3.5-inch waterway and put it on that intake. And now it doesn't matter. That's the choke point, right? Your badass water hauling machine and water moving machine, it can't get the water into it to be able to move it. If it can't get into the pump, you're not going to be able to move it, right? So that's where really making sure you do your homework, and understanding that if a valve is cheap, it's cheap for a reason, right? There's a reason it's cheap. And I know it's easy for me to say that because I'm spending your money, right? Or telling you how to spend your money. But I can assure you that the valves that are more expensive, they're more expensive because they perform better, right? And if you're going through all the work to build something like this, right, you want to make sure that you it can perform as good as it can, right? Now, one of the things that you mentioned, plumbing size and this, that, and the other, right? If you're trying to minimize loss and everything, we all know that front intakes are one of the worst ones from a flow perspective, especially drafting, right? Talk with your truck manufacturer and ask them what the largest plumbing that they can do for your front intake is, okay? In my experience, most of the manufacturers that I've dealt with, the largest that they have been able to offer me is 5-inch plumbing. Well, that's obviously neck down compared to your 6-inch side intake. So right there's going to be some loss. But your manufacturer may offer something bigger, but understand that may come with a trade-off, right? They may give you bigger plumbing, but that might start getting into your cramp angle, and now the rig can't turn like it would with smaller plumbing. So there's always that trade-off. But one of the things, especially fire departments that are using front intakes and are trying to flow respectable volumes through them, one of the things I cannot stress enough is if you're speccing a front intake on your rig, I recommend that you spec and carry a 25-foot section of 6-inch soft suction to connect to that front intake. Because now when you look at that hydraulically and you're using a fire hydrant and assuming that the fire hydrant has the volume, blah, 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 right? That 25-foot length of 6-inch hose only has about 3 pounds of loss at 2,000 gallons a minute. So when I hook that to the front intake and hook the other side to my steamer, right, that really is the equivalent of ripping the hydrant out of the ground and putting it right on my front intake. So the only loss is in the plumbing in the truck. And it came that way from the factory. You can't do anything about it. In my experience, all across every class that I've taught where we're doing this stuff, I can reliably expect 1,500 gallons a minute through a front intake using 6-inch soft suction on the front intake. And in some cases where the hydrants were strong enough, I've gotten 2,000 gallons a minute through a front intake alone, right? And it's because that 6-inch soft suction minimizes the friction between hydrant and front intake, and right, the rig is plumbed nice enough to be able to get that.
And on the flip side of that, the discharges is the same. We have to, our nozzles. We need to do research on the nozzles that we're using. Are they able to flow the water? If we're getting all this water in, well, on the intake side, we got to be able to push it out as well. So do your homework on those appliances as well.
Now, we talked about intakes, we talked about the discharge, but we haven't talked about, beyond the plumbing behind the pump panel, what the pump is doing in all this as we go. And you don't... Do you need to specify the largest pump you can put behind the pump panel in order to get all of that water out? Or and I guess where I'm going with this is I don't know how it works. I haven't done it myself, but I know you can get 2,000 gallons a minute out of a 1,500 gallon per minute pump. So first, I want to talk about how do you do that? Like what is it that you're doing that does that? And second, does that play a role in what, you're trying to build this, this water moving machine? You go with the biggest pump you can get and, hope you get the water, or do you go with something that might be rated a little lower, but you'll be able to get what you want out of it eventually? Bill, how does that work? How am I getting 2,000 out of a 1,500?
Well, on the roll side, if we're talking about a 1,500 GPM pump, it requires one intake at a draft to get that 1,500 GPM pump, or 1,500 GPM. usually the difference between a 1500 GPM pump and a 2000 GPM pump is one, a number of discharges, and two, the size of the motor of that apparatus. And how can we put less strain on that motor? And that's the way I get 2000 GPMs out of a draft on a 1500 GPM pump is to add that second or third tentacle, as Andy would say, the hard suction into that water source. And now we can draft at a lower RPM to get that same amount of water. So then when you raise up the RPMs, we're going to actually be pumping well over your 1500 GPMs. And far as, I'm sure Andy will talk about this on the suburban side, when we know we have a good main or a second water source, we will use either heavy hit the hydrant or bring in another apparatus that's hitting a second hydrant, so we can get that both intakes being used on that first new apparatus.
Andy, talk to me about that.
Yeah, so it's important to understand, and Bill hit on it. There are three variables that dictate a pump's rated capacity. So when I go and I say I have a 1500 gallon per minute pump, well, really there's three major things that dictate that rating. The first is the impeller size, right? The size of that impeller. Mm-hmm. Okay. The bigger the impeller, obviously the more water it can get in, therefore the more water it can get out. The second, like Bill said, is the number of discharges. And we already talked about that. The standard says I got to have X number of discharges to be able to move my capacity. And then the third, and often, in my opinion, the most overlooked, is that vehicle horsepower, right? The horsepower of the vehicle's motor, right? Because the bigger the motor, the more power that it has, the more power it's going to have to actually spin that impeller and get rid of that water, right? So that's one reason why I tell people, if you're serious about building a water machine, right, don't skimp out on the motor, because right, that's the most important part of it. Now, it's the easiest one to skimp out on because it's usually the most expensive component on your rig if you look at it just that item, okay? So I understand that. But one of the things, like your question is, how are people getting 2,000 gallons a minute out of a 1,500 gallon per minute pump? One of the reasons is, if you look at most of your pump manufacturers, right, a lot of people think that truck manufacturers have a rack of different size pumps, and when you say you want a 2,000 gallon per minute pump, they're going down their shop and saying, okay, well, here's the 750s, here are the thousands, here's the 1250s, and so on and so forth, until they find that 2,000 and pull it off the rack and put it in your rig. It's not how it works, right? Most of your pump manufacturers, they basically, for the municipal engines, they build two size impellers that are in casings, right? There's a 750 to 1250 size range, and then there's this 1500 to 2250 range. So when I spec my rig and say, hey, I want a 1500 gallon per minute pump, they're pulling the larger of the two sizes and putting it in your rig. So depending on the discharge configuration you have on your engine and the motor you put in your rig, you may have inadvertently built a 2,000 gallon per minute pump that was rated as 1,500, right? And we did that with our tower ladder, our Quint tower ladder in the city of Charlottesville where I work, right? It had enough discharges to be a 2,000 gallon per minute pump. It had a big horsepower motor because it was a Quint tower ladder, but it was rated as a 1,500 gallon per minute pump. And the reason that they did that originally is they told the manufacturer, hey, we want you to rate this at a 1,500 GPM pump. We know it's 2,000, but when it comes time to pump testing, because it was rated at a 15 from the factory, this rig will never have a problem passing its pump test, right? Because it actually has more in reserve. It can move more than it's rated for. Okay, so that's part of it. The other thing too to remember is, when we're talking about the flow rates and the volume capacity and everything like that, there are considerations and variables that dictate discharge pressures. So when I tell you that I have a 2,000 gallon per minute pump, I'm really not telling you the full statement. Now, a pump nerd like us, we would know what that statement is. That statement, that full statement is, I have a 2,000 gallon per minute pump when it is drafting through two suction lines, two intakes that have 20 foot of 6-inch hard sleeve apiece on either side, with a net pump discharge pressure of 150 psi and no more than 6 feet of lift present. Nobody's going to say all that, but that's what that rating means. So with that being said, it's important to understand that a pump gets its maximum flow capacity, or 100% its rating, at 150 psi. If I bump the pressure up to 200 psi, now my capacity drops to 70%. If I go to 250 psi, now I'm at 50%. So as the pressure goes up, the capacity drops, okay? Well, if the pressure drops, technically your capacity goes up too. So if I want to exceed a pump's rated capacity, let's say I have a 1,500 gallon per minute pump and I want 2,000 gallons a minute out of it, on my discharge side, if I have the right hose and configurations on the supply side to minimize friction for my pump operation, and I only need to pump at 100 pounds, well, now I'm below that 150. So technically, I can expect more than the pump's rated capacity. And if you look at this is what's kind of cool. If you look at how industrial pumpers are rated, that's how they're rated, right? So industrial pumpers are anything over 2250. So if I get a 3,000 gallon per minute pump, well, if you look at that pump certification plate, that's 3,000 GPM at 100 PSI. It is 70% at 150 PSI and 50% at 200 PSI. Okay, so they're actually derated in pressure 50 pounds below what the municipal fire side is rating things at. Okay, so it's important that it works in both ways, right? If I were to take that industrial pumper and try and pump at 250 pounds, I'm going to get way less than 50% of that rating, okay? Because the water's leaving faster than it can build pressure.
I think one way of sort of summarizing what you just said with all that is we really do, when we're speccing these things out, and it doesn't only have to be for massive water movement. It's just speccing it out in general. It's a package. It's truly a package of the pump and the engine, and the pump and the discharges. If one of those things is off, you're not going to get what you want. If the engine can't provide the power, you could have a 4,000 gallon a minute pump and it's still not going to get you anything. But if you have the motor and the pump, but you don't have enough discharges to get that GPM and out, then you're not going to. So it really is, a package deal. It's almost like packaging your nozzle with your hose line, to make sure that, you're getting the maximum out of that nozzle that you're supposed to get.
I want to add one thing to that real quick. If I could add one thing to that, sure. Calling it a package jarred something in my head, and I really like that how you said that, Chris. One of the things that I recommend to folks that are listening to this and that are building rigs and trying to do this, something that your apparatus manufacturer can do, if you ask them, is they can do it's basically a horsepower report, and they can plug in, when you tell them what size motor you want and what the pump size is and what the pump rating is, all that, they can tell you and basically do a computer model that says, under full load, flow in the pump's rated capacity, the motor will have X number of horsepower in reserve. All right. So that's really important to me, because I have seen guys that run that report thinking, hey, we're trying to save money. We're going to get the smaller horsepower motor, but we still want that 2,000 gallon per minute pump. And the manufacturer says it can do that. We'll run that report, and they find out that after running that report, that 450 horsepower motor is only going to have 2 reserve horsepower left. Can it do it? Yeah, it can do it when it's new, but after I beat the hell out of it for 10 years, is it still going to do it? That's for you to figure out. And it may be worth saying, okay, well, give me the next size motor in there and run the same report. Oh, I have 40 reserve horsepower or whatever it may be. So that's something that I recommend that you look at and ask your truck manufacturers to provide you with, so you can get a good idea of really what to expect with your rig and what is worth your money, right? Is it worth it or is it not?
We have covered a tremendous amount of ground, I feel like, during this today. But I have to think there are probably things that I didn't hit on that either or both of you think that I should have. So, Bill, I'll start with you. Is there anything else, any other comments about this, or anything that I missed that we didn't cover that you think like, oh, man, if we're going to talk about that, we got to talk about this, that kind of thing? Is there anything else, or just any general comments?
No, we talked pretty much about everything I wanted to today. I do want to mention that we're talking about moving large volumes of water. And this is something we don't do on every fire. You know, those room and content fires, we're not doing this. This is those large scale fires that you may have only once in your career. But when it comes, you want to be prepared for it. And the things that we talked about today is what you can do to be prepared for that. When those large scale fires happen, you don't want to try and figure it out there. You want to figure it out beforehand. So once you get all this package deal of an apparatus, go out there and train with it and be able and show that you can move those large volumes of water.
Andy, how about you? Anything I missed? Any final comments? Anything that you wanted to hit on that I didn't ask about?
I think, like Bill said, right, we covered everything that I think was a must cover topic in this podcast for this discussion. So I'm tickled about what we talked about. The only thing that I would bring up and make sure that the viewer understands is one other facet of this that you absolutely have to consider is, what is your hose bed going to look like, right? How are you going to set your hose bed up when you build a rig that is a water moving machine, right? This is, if it's a true water supply unit or something like that, this is one of those instances where I really might want to think about putting a split bed of large diameter hose, whether it be 4-inch or 5-inch. So that way, if I'm on this large incident and this unit gets called to be able to move the water, well, yeah, we can get water into the pump and we can get it out of the pump, but we have to be able to get it between our rig and wherever it's going. And that's where hose comes into play and the appropriate hose layouts and things like that. If I can lay dual supply lines once as opposed to having to lay one and then hand jack the other, that's a major win. And if I set my rig up and think about what is my hose bed going to look like, am I going to be a little bit lighter on some of the attack lines because I want to be heavier and have the room to carry more supply line? That is something that absolutely needs to be discussed in your committee, and why it's so important from the beginning to look and say, what is our mission? Is it an attack engine that can move a lot of water, or is it a water supply piece that can move a lot of water? Those are two different engines, in my opinion.
All right, guys. Well, again, my thanks to you for sitting down. I think it was worth the wait, getting you both on the same podcast again. If anyone has topics that you'd like us to hit on this podcast, let me know. I'm at chris.mcloone@clarionevents.com. We'll put Bill and Andy to the test on that. If there are other topics in general you would like me to hit on, please let me know. And we have a host of subject matter experts that we can tap into to get that answered for you. All of our podcasts are archived at fireapparatus.com/podcasts. So if you go there, everything that we've done so far is there. We're also available on most of your social media platforms and other podcast platforms like a Spotify or something like that. So again, Bill and Andy, thank you very much for joining me today. This has been Chris Mc Loone with Fire Apparatus and Emergency Equipment. Have a good one and stay safe. Thanks again, guys.